All right, today we're going to jump into the absolute foundation of algebra, one-step equations. Now, if that sounds a little scary, I promise by the end of this, you'll see it's really just like solving a fun little puzzle. You know, when you really get down to it, algebra is all about solving mysteries. See that little letter X in there? Just think of it like it's a treasure chest. And our job, our whole mission, is to figure out what number is hiding inside. So the real question is, what's in the box? And a great way to think about this is like you're unwrapping a gift. To get to the good stuff inside, right? You have to undo all the wrapping and the ribbons, one layer at a time. It's the exact same idea here. We're going to carefully unwrap the equation to find out what X really is. But before we can start unwrapping anything, there is one rule. One single rule you absolutely have to know. We call it the golden rule of equations. And honestly, it's the most important rule in all of algebra, period. And here it is. It's this simple. Whatever you do to one side of an equation, you have to do the exact same thing to the other side. This isn't just a suggestion, folks. It's a law. If you add 5 to the left, you've got to add 5 to the right. If you subtract 10 from one side, you've got to subtract 10 from the other. No exceptions. And here's a great way to picture why this is so important. Think of that equal sign like it's the middle of a perfectly balanced scale. If you add a little bit of weight to one side, but you don't add the exact same weight to the other, boom, the scale tips over and it's not equal anymore. This rule just makes sure your equation always stays perfectly balanced. Okay, so we've got our golden rule down. Now, let's talk about the tools you're going to use for the actual unwrapping part. Think of this as your special toolkit for solving the mystery. We call them inverse operations. And the best part? Our toolkit is super simple. For what we're doing today, we only need these two tools, and they're perfect opposites of each other. Addition cancels out subtraction, and subtraction cancels out addition. That's it. That's the whole secret. These are the keys to getting X all by itself. Okay, enough talk, right? Theory is great, but let's actually do this. We're going to walk through a few examples together, starting with a basic one and then moving to something a little trickier. Let's see these tools in action. Okay, first up, X plus 15 equals 42. Our whole goal here is to get X all by itself. So first thing you ask yourself is, what's happening to X right now? Well, a 15 is being added to it. So step 2, we grab our inverse tool. The opposite of adding 15 is subtracting 15. And because of our golden rule, we do it to both sides. Then you just do the math. 42 minus 15 gives us our answer. X equals 27. And just like that, you've solved it. Let's try another one, this time with a negative number. Don't let that throw you off. The steps are exactly the same. We have m minus 8 equals negative 3. Okay, step 1, what's happening to m? And 8 is being subtracted from it. So, step 2, what's the inverse of subtracting 8? It's adding 8. So we add 8 to both sides. Now, you just have to do the math on the right side. What is negative 3 plus 8? Yep, it's 5. So m equals 5. All right, what about this one? 4 equals y plus 9. I know what you might be thinking. The variable's on the right side. A lot of people see this and they just freeze up. But guess what? You don't need to. The process is identical. Just focus on the side that has the variable. In this case, the y plus 9 side. To get y alone, we need to get rid of that plus 9. So step 2, we subtract 9 from both sides. On the left, 4 minus 9, well, that gives us negative 5. And that's it. That's the answer. Negative 5 equals y. Okay, so you've seen how to do it the right way. Now let's spend a second talking about how it can sometimes go wrong. If you know what not to do, it's going to make solving these so much easier and you'll avoid some common traps. Okay, zoom in on this because this is super important. Let's look at that first mistake. You've got x plus 5 equals 12, and for some reason, people want to flip it and do 5 minus 12. Nope, you always start with the number that's already waiting on the other side. It has to be 12 minus 5. And the second big one, forgetting to use your inverse tool. For x minus 6 equals 10, you're trying to undo the subtraction, so you have to add 6. If you subtract again, you're just getting further from the right answer. So at this point, you might be asking yourself that classic question, am I ever actually going to use this stuff? And the answer is yes. In fact, you probably already used it today and didn't even realize it. Let's look at why this really matters outside of the classroom. Picture this. You're at a restaurant, you get the bill. The total says $25, and you can see that 2 of that was tax. So how much was the meal itself? You probably just solved that in your head, right? Well, you just did algebra. Because here's what your brain did without even thinking about it. It set up this exact equation. The price of the meal plus the $2 tax
equals the $25 total. So what did you do in your head? You subtracted the 2 from the 25. You just used an inverse operation to find the variable. You found out the meal was $23. See? You're a natural at this already. So let's just take a step back and look at what we've done. You now have the bedrock, the foundation for solving any one-step equation using addition and subtraction. You get the golden rule, you get inverse operations. That is a huge deal. Which brings us to one last thought. You've totally got addition and subtraction down. But what happens when things get a little spicier, when multiplication and division show up to the party?